So I'm on slide 10 of our chapter 5 slideshow. This is the probability of a certain number of pounds of waste. So trying to come up with a story here. Maybe this is a city trash collection company, and some weeks they pick up less trash, and some weeks they pick up more trash, and their average is 1,100 pounds of trash. So it's obviously a continuous random variable because you could get decimals, and the shaded area represents the likelihood of having between 800 and 1,400 pounds of waste. And I will point out, and this confused me for a while, we don't really look at that vertical axis any longer. What we need to do is just look at this shaded area. So the shaded area is what gives us the probability. And you might be wondering how we find probability. How do we find that shaded area? Well, that's coming up. Oh, and real quick, the population mean is 11. That's the center of this distribution. The probability of the variable taking on any particular value is 0. We touched on that already. And that's because there are infinite possible values of x. So the pink area represents the probability that x is between 8 and 14. And I already said that. The probability is the area under the curve. The normal distribution, so here we go, the bell curve, the normal distribution is a continuous probability distribution. If a continuous random variable is normally distributed, then here comes the empirical rule. The likelihood of being within one standard deviation of the mean is 68%. So this is one standard deviation away from the mean, and again, the mean is right there in the middle. Mu is the letter that I'm writing. And the probability of being within two standard deviations of the mean is 95%, and then 99.7% of all the data values are going to be within 3 standard deviations of the mean. So now I think we are ready for question 8 on your activity sheet. X is a continuous random variable. Now this is the empirical rule, just illustrated slightly differently. See how this is 68% right here? And then if we added 13.6 plus 34.1, and then added that again, so this is 68%, this adds up to about 95%. And then if you add all of these up, it's about 99.7%. So those values are the same values I was telling you before, but now we've broken the bell curve up into regions. I'll erase that for now. Okay. Based on this graph, find the probabilities of the following as percents. What is the probability that x is more than one standard deviation above the mean? So what is the probability that x is over here somewhere? Oh, and also let me point out that sigma, this is the lowercase sigma Greek letter, and that represents standard deviation. So the probability that x is more than one standard deviation above the mean, I'm going to take 13.6 plus 2.1 plus 0.1. Let's see, that's going to be 15.7, so 15.8%. What about the probability that x is less than 2 standard deviations below the mean? So what is less than 2 standard deviations below the mean would be this region, or this shaded area. So that's going to be 2.1 plus 0.1 is 2.2%. What is the probability that x is within 1 standard deviation of the mean? Well, before I told you it was 68%, and here it looks like it's going to be 68.2%. I'm not going to worry too much about that distinction. The 0.2 is no big deal. And then x is within 2 standard deviations of the mean. Well, we can take our 68.2 and add 13.6 plus 13.6, and I'm hoping that that comes out to about 95. .4 is what I'm coming up with. So we are proving the empirical rule. We're just working from a different diagram here. And if we hop back over to our worksheet, we're almost done with page 2 here. The total area under the curve is, this is all the possible likelihoods. So it's 1, which is 100%. Probability is found for ranges of x values rather than individual x values. Okay, the probability c less than x less than d really means the probability that x is between c and d. And finally, the probability that x is an actual specific number is 0.